Hi friends, no? So welcome to our topic for today, no? So let us continue the discussion regarding conversion of number systems. So we have already discussed the conversion of binary numbers to other number system and the conversion of octal number system binary and decimal number systems to other number systems, no? So today we will be discussing octal to other number systems and hexadecimal to other number systems. So for this example, no, so let us convert octal numbers to binary numbers, no. So from base 8 gagawin natin base 2 yung ating mga numbers natin, no. So how are we going to approach this is the inverse process of binary to octal. Diba? We already discussed binary to octal wherein we have grouped our digits, our binary digits into 3. Then we are going to find the equivalent sum, no, ng equivalent niya sa decimal, no. So yung 4, yung 1 to 4, no. So dito ganun din, but instead we will do it digit by digit for octal, no. So for example, in this case now we have 137 base 8. What is the equivalent to base 2? So just write the numbers na magkakahiwalay. Okay, so you will be able to put the equivalent ones, no, appropriately. So you can put the groupings, no, para hindi kayo malito. So let's say we have 1 2 3 1 2 3 then 1 2 3. So ganun din yung process natin. We have 1 2 4, ilalagay natin from right to left per group, no. So we have 1 2 4 1 2 4 1 2 and 4. Okay, so tapos lalagyan niyo lang ng marka na 1 lahat ng places na kung saan yung sum nila ay magiging yung digit. In this case, for example, 7. Ano dito sa 4, 2 and 1 yung kailangan natin para magkaroon tayo ng sum na 7? 'Di ba lahat 'yon? So 4 plus 2 is 6 plus 1 is 7. So lahat sila lalagyan mo ngayon ng 1. Okay? Proceeding to the next digit, we have 3. So we have 2 plus 1. So we have 1, 1. Of course, 0 si 4. Okay? Then for 1, no? 1. Then 0, 0. So our answer, we can drop the insignificant zeros, no? Yung nasa pinaka-right, leftmost natin rather. So, ayan. So, wala na yan. So, therefore, our answer is 1, 0, 1, 1, 1, 1, 1, base 2. Ayan. So, this is our answer for our example number 1. How about the second example? No? So, ganun din, digit by digit, and same din kapag meron tayong fraction. In this case, we have 0.17. Diba? So, we have 5, 2, 3, 0, of course, point, then 1, 7. Okay, so, just put the 3 places, no? Below all the digits para madali ninyong makuha. Point. Ayan. So, you can start wherever, no? But, we are going to place, rather put our equivalencies first. So, we have 1, 2, 4. Then, sunod-sunod lang, no? Ayan. Okay, so, ganun din, katulad ng ginawa natin kanina, even for the decimal places. So, again, for 7, we need all the 3. Then, for 1 naman, we need yung 1 lang, then 0 na itong dalawa. Diba? Then, for 0, of course, wala. Okay, then we have 3. So, we have 0, 1, 1. Because 2 plus 1 is 3. Then, we have 0, 1, 0 for 2. And for 5, we have 1, 0, 1. So, therefore, we have our answer, no? For our octal to binary, we have 1, 0, 1, 0, 1, 0, 0, 1, 1, 0, 0, 0, point, 0, 0, 1, 1, 1, 1. Okay, so this is base 2 and this is our answer. Okay, so that is how we convert octal to binary number system. Okay, so how about paano naman kung uh, octal to decimal, no? So just like what we did with octal to binary, we are going uh, to do this bitwise or rather digit-wise, no? So and we have two methods for this one. So dito ko na sa taas ilalagay. So, ang ating method number 1. So, pwede nyo gawin, since we already know yung octal to binary, is you can convert octal first to binary. Then, after you've converted it to binary, you can convert it to decimal. Okay, yan yung method number 1 natin. No? Which is kind of lengthy. No? Pero if you are not aware of how to convert octal to decimal, then you can proceed with method number 1. Yung method number 2 naman natin yung direct. No? So, we're going to place this we're going to write rather our given 137 just like this one. Then we're going to multiply it by 8 lahat. Of course, with our exponent kung pang ilan yung placement ng ating digits. Now, we will always start with 0 from the right. No? So, from the right going to the left. Okay, so start tayo sa 0. So, we have 8 raised to 0, 8 raised to 1, and 8 squared. Okay, then just get the equivalent. No? So, we have 8 squared is 64 times 1 is 64. 8 raised to 1 is 8 times 3 is 24. Then we have 8 raised to 0 is 1 times 7 is 7. So just add them, no? So we will have 4 plus 4 is 8 plus 7 is 15. Carry 1. Then we have 1 plus 6 plus 2 is 9. So therefore, here is our answer, no? So we have 95 as it's equivalent to our decimal, no? Yung ating octal. Then ganun din dito, no? So from the decimal point for our second example na. So from the decimal point going to the left and from the decimal point going to the right. Okay, so just write it 5230. So of course times 8 raised to 0 times 8 raised to 1 pataas na increasing exponents. Yan. Then yung kabila naman, no? So we have 1, 7, decreasing exponents naman, starting from 8 raised to negative 1. Okay, so ganun yung placement natin. So we have therefore 8 raised to 0 times 0 is still 0. 8 raised to 1 times 3 is 24. Okay, so we have 64 sa 8 squared times 2 is 128. Then we have 8 cubed times 5 that is 2,560. So just add all of this. No? So we have 0 plus 8 plus 4 that is 12, carry 1. 1 plus 6 is 7 plus 2 is 9 plus 1 is 11. 1 carry 1. So we have 1 plus 5 is 6 plus 1 is 7. Then bring down 2. So ito pa lang yung sa whole number. So whole number pa lang yan. Paano yung sa kabila? So we have 8 raised to negative 1 is equivalent to 1 over 8. So that is 0.125 in fraction, in fractional decimal. So si 8 over si 8 raised to negative 2 naman times 7 is equivalent to 1.09 something na meron pa siya kadugtong. So since this is decimal, we can just simply round it off. So add nyo lang. So we have 14 carry 1. We have 3, then we have 2, tapos 0.234. So, add nyo lang yung dalawa. No? Ayan. Add nyo lang sila. So, therefore, we have our answer. Our final answer is 2712.234 base 8. Base 10 rather. So, sige, let us check the exact value of 1.09. So, you can bring out your calculators. So we have 7 times 8 raised to negative 2. That is 1.09375. So we can add that, no? Para sakto. 375. Ayan. Okay, so we have 2, 3, 4, 375. Base 10. Ayan. Okay, so that is our equivalence, no? Yung equivalent natin for octal to decimal, no? So, I hope malinaw, no? So, next, paano naman si octal to decimal? So, for this one, no, we are really going to pass through the binary number system. So, we're just going to convert first octal to binary. Di ba alam naman na natin yan, yung octal to binary. So, we have again, the method is octal. Go to binary. Then go to hexadecimal. Okay, so we have 137. So this is 001, 011, 111. Okay, tapos kapag ka nalagay nyo na yung binary equivalent nila, i-group nyo naman yung binary equivalent into 4. No? So we have 1111. Magkakaiwalay. Isin natin. 1111. Then group, no? Hanggang dito. Then hanggang dito. So yung 0 sa dulo, kahit hindi nyo naisulat yan, insignificant naman na yun. So we have 1010. So we have 1248. 1248. No? So therefore, we have complete to. So this is F. Then we have 4 plus 1, that is 5. So therefore, the equivalent of 137 base 8 in hexadecimal is 5F. Okay? So, ganun na mag-convert. Then, we have for this one, so, 5230.17. So, this is equivalent to 101. Diba? Then, we have 010. For 3, we have 011. Of course, 000 to. Then, we have 001 for 1. And for 7, 111. Okay? Then group nyo lang rather into 4, no? So coming from the decimal point, going to the left sa ating mga whole numbers, going to the right sa decimal numbers natin. So we have this one and this one. Then dito sa kabila, ito naman. Yung mga kulang, pwede nyo lagyan ng 0 na additional, no? Para hindi kayo malito sa pagbibilang. So we have 1, 2, 4, 8. So this is 8 obviously. We have 1, 2, 4, 8. 8 plus 1 is 9. Then we have 1, 2, 4, 8. 8 plus 2 is 10, which is equivalent to A in hexadecimal. So we have point. So this is 1, 2, 4, 8. So that is 3. Then we have 1, 2, 4, 8. So we have 8 plus 4 is 12. Then 12 is equivalent to C in hexadecimal. So therefore, our answer is A98.3C base 16. Okay? So, ayan. This is our answer. Okay? So, I hope malinaw guys, no? So, that is for our octal to hexadecimal. Next. So, let's tackle naman hexadecimal to other number systems. Alam na natin yung octal to other number systems. Then, ano na lang remaining natin? Our hexadecimal. So, for hexadecimal to binary, just like what we did for octal to binary, no, ganun din yung gagawin natin except our place values are 4 instead of 3. No, so per digit, we have 3 to A. Tapos kunin nyo lang equivalent 1, 2, 3, 4. 1, 2, 3, 4. Usog natin yung A. So dito natin lagay si A. 1, 2, 3, 4. Okay, so again, that is 1, 2, 4, 8. 1, 2, 4, 8. 1, 2, 4, 8. No? So, same, again, same process for binary to hexadecimal, pabaligtad lang. So, we have 3. So, 1 and 2 lang ang kailangan natin. So, we have 0, 0 for this one. So, we have 2. So, 0, 0, 1, 0. Then, we have 8 that is equivalent to 10. So, we have 1, 0, 1, 0. So, drop the insignificant 0. So, therefore, our answer is 1, 1, 0, 0, 1, 0, 1, 0, 1, 0. Base 2. Ayan. Okay, so this is our answer for example number 1 sa hexadecimal to binary. So, paano naman yung kabila? Ganun din. So, we have 78A.1B. So, instead of tatlo, 4 yung i-group natin. So, for 7, that is 0, 1, 1, 1. Diba? 1, 2, 4, 8. So, 1, 2, and 4 lang yung kailangan natin. Then, we have for 8, that is 1, 0, 0, 0. Kasi 8 yung pinakadulo. Then, for A, we have 1, 0, 1, 0. Diba? That is 8 plus 2. That is 10. Point 0, 0, 0, 1. That is for 1. And for B, this is 11. So, 1, 0, 1, 1. Okay, so ito na yung answer natin. No? So you can just drop the insignificant zeros again, just like what we did in the previous example. So we have 1, 1, 1, 1, 0, 0, 0, 1, 0, 1, 0, point, 0, 0, 0, 1, 1, 0, 1, 1, base 2. Na yan. Okay, so that's how we convert hexadecimal to binary. Okay, so I hope naintindihan, no? Wala tayong questions for that, hopefully. Ayan. Sige, so how about hexadecimal to octal, no? So, for hexadecimal to octal, katulad lang rin ng octal to hexadecimal, pabaliktad nga lang. No? So, hexadecimal, convert mo muna sa binary. No? So, hex, convert sa binary, then convert sa octal. Di ba madali lang naman mag-convert ng binary to octal? So, we have here 3 to A. So, again, 3 to A. So, we have 0, 0, 1, 1. Then we have 0, 0, 1, 0. Then we have 1, 0, 1, 0. Yan yung equivalence nila. Then, group nyo lang into 3. Ayan. So, we have 3 digits. So, we have 1, 2, 4. 1, 2, 4. 1, 2, 4. 1, 2, 4. So, we have here 2. 4 plus 1 is 5. Then, we have 4 and we have 1. So, therefore, we have our conversion from hexadecimal to octal. We have 1, 4, 5, 2 base 8. Ayan, ganyan siya. Okay? Then, we have here yung kanina natin, no? 7, 8A, 0.1B. No? So, wala ko lang konti. So, this is from hexa to binary. So, we have 0, 1, 1, 1. We have 1, 0, 0, 0. Then we have 1, 0, 1, 0. Point 0, 0, 0, 1. Then we have for B that is 1, 0, 1, 1. Okay, lagi nyo lang tatandaan 1, 2, 4, 8. Tapos hahanapin nyo lang ano yung tawag dito, yung pinag-a-add natin to get our digit, no? We have for 7, this one. For 8, this one. For A is this one. Then we have for 1 is this, and we have for B this one. Then group nyo lang into 3, no? So again, coming from the decimal, going to the left sa whole number, going to the right sa fraction natin. So group, 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 then we have group, group, then add 0 kung may kulang, no? Kung may kulang lang naman. So we have 1 plus 2 is 3, 4 plus 2 is 6, 1 plus 0 is 1. Then we have 2, no? 1, 3, 3, 6, 1, 2. Point. This is 0, 0. No, of course, this is 0. 4 plus 2 is 6. Then we have 4 plus 2 is again 6. No, so therefore, our final answer is 3612.066 base 8. Ayan. This is our answer for our second example. Okay, I hope malinaw guys yung conversion natin, no? So, okay, last part, no, for the conversion ng hexadecimal to other number system. So, we're going to do hexadecimal to octal naman. So, or rather decimal, hexadecimal to decimal. So, just like what we did with octal to decimal, no? So, by digit ang pagmumultiply. But instead of base natin ay 8, ang magiging base natin ay 16. So, we have 3 to A, 3 to A. So again, no, just multiply yung pinaka-rightmost, that is 16 raised to 0. Okay, lagi tayo mag-start sa raised to 0. So we have times 16 raised to 1, then we have times 16 squared. So we have, therefore, 16 raised to 0 is 1, no, times a 10 10 is a, so we have, gay ko dito. Alam naman natin yan yung conversion niya. So we have 10 times 1, that is 10. 16 raised to 1 is 16 times 2 is 32. Then we have 16 squared, that is 256. Okay, times 3, that will give us 768. So adding all terms, no, so we have 8 plus 2, that is 10, carry 1. We have 1 plus 7, 1 plus 6 is 7, plus 3 is 10, plus 1 is 11, carry 1. So 7 plus 1 is 8. No, so therefore we have our answer, 810 base 10, no, for our decimal conversion ng ating hexadecimal number. Ganun din sa kabila, no? So for the fractional part naman, katulad lang rin sa octal, no, 16 raised to negative 1, 16 raised to negative 2. So we have 7, 8A, 1B. So, times 16 raised to 0, times 16 raised to 1, times 16 raised to 2 or squared. So, this is equivalent to what? Of course, 16 raised to 0 is 1, times A is 10. Diba? Remember, A is 10. Then we have 16 times 8, that is equivalent to 128. Then we have 16 squared times 7, that is 1,792. So, adding all the terms, no? So, we have 2 plus 8, that is 10. Carry 1. 1 plus 9 is 10, plus 2 is 12, plus 1 is 13. Carry 1. We have 7 plus 1, that is 8, plus 2 is 10. Carry 1. So, we have 1 plus 1 is, yeah, 1 plus 1 is 2. Sorry. Sorry. 1 plus 7 is 8, plus 1 is 9. And my apologies. No, so we have, bring down na lang yung 1. So we have 1,930 for the whole number part. Para naman sa fraction. So times 16 raised to negative 1 times 16 raised to negative 2. This will be equivalent to what? So we have 0.0625 for the top part, yung 1 times 16 raised to negative 1 natin. Then yung sa baba is 0.0430 or 43 na lang. Now, tas we're just going to add, no? So we have 5, 5, 10, carry 1, so 1.0. Okay, so add lang natin yung dalawa. Itong dalawa, add lang natin. So therefore, our final answer is 1930.1055. Ayan. So this is our answer for the conversion from hexadecimal to decimal number system. Okay, so last topic for this session. So let us discuss other number systems. Now, so we have first one, the binary coded decimal. So in computing and electronic systems, BCD is a class of binary encodings of decimal numbers where each digit is represented by a byte. No, so when we say a byte, that is 8 bits. No, so for instance, a 12-digit decimal number would be represented as a 12 bytes of data. So we have here our example. Yung una muna natin, 246 base 10. No, so 246 base 10. So just like what we did with hexadecimal, no? So hanapin lang natin yung kanyang equivalent binary, no? So of course hanggang ito, so apat na places dito and apat din dito sa kabila. Okay, so we have 2. Ano equivalent niya sa binary? That is 0010. Okay, yan yung 2 natin, di ba? 1, 2, 4, 8. Yan, dyan ang galing yan. Then we have 0100. That is for 4. And for 6, we have 0110. Okay, so question, sir, magdadrop ba kami ng digit dito kahit insignificant? No. No, hindi kayo magdadrop kapag ka binary coded decimal kasi we are after the bit size. So therefore, the answer is 0010, 10100. We have 0110. Okay? So I'll give you the last, I'll give you the last two examples in this case, yung 2 and 3, to try this on your own, yung binary coded decimal natin, no? So para ma-practice kayo. So, yun. Then we have our gray code, no? So when we say gray code, this is also known as the reflected binary code or the reflected binary. Is an ordering of binary numbers such that two successive values differ only in 1 bit. No, so we will start off things with 000. Diyan tayo mag-i-start, no, dito. Okay? For RBC, so change lang tayo ng rightmost, no? Una lagi ang rightmost. Yan. So, yung rightmost bit, yung first natin i-check kung tawag dito to check kung nagbago na or hindi or dapat ba natin siya baguhin. Then if If change is not acceptable or change is not valid, so proceed with the next value to the left. Ayan. Okay, so just like with this one, no? So start nga na tayo kay 0. So yung rightmost natin, no, yun change natin. Hence our bold digit 1. Okay, so hindi natin pwede baguhin si 1 ulit kasi kakabago lang niya. Proceed tayo sa ano niya, sa left niya. So yung 0, yan yung magcha-change. So therefore we have from 0 magiging 1. We have 1 1. Okay? Next, no? So again, ano, rightmost lagi ang titignan natin. So, pwede nating i-change to kasi ang nagbago naman is yung kabila. Diba? So, therefore, we have 1, 0 no, after the change. Then, we cannot proceed with the change of 1 again. No? Bakit? Kasi magsi-0, 0, 0 siya. Babalik siya sa una. So, kapag ka ganun, skip kayo, proceed kayo sa susunod. No, in this case, ano yun? Ito. No, yung may underline na yan. So, change natin yan. So, we have 0, 1, 1, 0. Then, ang susunod natin change, yung dulo ulit. Kasi wala naman siya kaparehas kapag na-change natin. So, we have, ayan. So, ito na yung sagot, yung 0, 1, 1, 1. No? Then, change natin yung susunod kasi hindi pwede yung last part. Kaka-change lang yan. So, we have 1, 0, 1. No? Then, for the last one, no, anong kailangan natin gawin? Yung rightmost ulit. No? Kasi wala pa naman tayo equivalent. Therefore, we have 100. Okay? That is how we convert binary or decimal numbers to gray code, no? So very important yan in the field of computer science and electronics engineering. So take note of that. Okay, so that's it. End of lecture. So I hope you guys learned something, no? So kung may questions, just drop it in the comments below or you can chat me through my channels. No? So ingat kayo palagi, stay safe and God bless.